In chapter 26, we will study about electric field. The mathematical definition of electric field is given by E equal to F divided by Q0, where Q0 is the positive test charge. The SI unit of electric field is Newton per coulomb because force is newtons and the SI unit of charge is coulomb. But in chapter 28, we will see that the SI unit can also be written as volt per meter. Electric field is a vector quantity, as can be seen from this definition. Since force is a vector and the test charge is a scalar, the direction of the electric field is the same as the direction of the electric force. Let me expand this concept a bit more. So consider a positive charge plus, and we are interested in calculating what is the electric field at any point P. Now, to get the direction of the electric field, what we will do is we will place a test charge Q0 at the point P where we are interested in calculating the electric field. Now, since this is positive and the test charge by definition is positive, there is a force of repulsion on charge Q0. And it can be seen that the force will act in this direction. So therefore, this arrow gives the direction of the electric field at point P because of the positive charge Q. Instead of a positive charge, if we were to have a negative charge, let's say this is my negative charge, then the direction of the electric field at point P can be determined by noting that Q0 is a positive charge and this is a negative charge. So there is a force of attraction on the test charge, and that force is directed along this orange arrow. So therefore, the electric field at point P because of the negative charge is given by this. Now that we have determined what the direction of the electric field is, let us now present the formula for calculating the electric field due to a charge Q at any point P. So the magnitude of electric field at any point P is given by 1 by 4 pi epsilon naught Q divided by R square. So if this distance from the charge Q, if this were R, then this formula is used for calculating the electric field. Notice that this gives only the magnitude of the electric field. Magnitude of electric field at the point P where we are interested in. The directionality of the electric field is determined as explained earlier in this lecture. Now let us introduce another important concept in this chapter, that is principle of superposition of electric fields. In chapter 25, we have seen the principle of superposition of electric forces. Here, we will discuss the principle of superposition of electric fields. Consider a set of charges Q1, Q2, Q3. For the sake of simplicity, we are choosing only 3 charges, and the generalization to more than 3 charges should be obvious. We are interested in calculating the electric field at this point P. Once again, for the sake of simplicity, we choose Q1, Q2, Q3 to be positive charges. So let this be positive. Now, principle of superposition of electric fields states that if you want to calculate the electric field at any point P, you set up the electric field due to each point charge independent of the other point charges, and then take the vector sum of all the resulting electric fields. So Q1 generates an electric field in this direction. How do I know it is in this direction? It is easy, because if I were to place a test charge Q0, since test charge is positive and Q1 is positive, there is a force of repulsion as shown by this arrow. Note, when I am depicting the arrow due to Q1, I am doing it independently of charges Q2 and Q3. Now let me draw the arrow corresponding to the electric field due to Q2. Once again, since Q2 is positive and the test charge is positive, there is a force of repulsion. And finally, due to Q3, it will be in this direction. So let us now label all the directions. Electric field due to charge 1, electric field due to charge 2, electric field due to charge 3. The principle of superposition states electric field at any point P is equal to the vector sum of all the electric fields E3, and the generalization to more than 3 charges should be obvious. A very useful formula that will be used many times in this chapter is given by force equal to Q times E. Kindly note, the electric field that is present here is not the electric field that is generated by this charge. So suppose we have an electric field at point P that is given by these arrows. Then our question is, what is the force on Q if I were to place at this point? And the force on this charge Q is given by this particular formula. In the next lecture, we will look at a couple of examples of the principle of superposition of electric fields.